Alrighty. All right, welcome back, guys. So I'm here to talk to you guys a bit about Data Mapper. So for those who don't know, Data Mapper just became generally available, and Data Mapper supports XML and JSON formats. It provides built-in mapping functions, a map checker, and a manual mapping test. So this exciting new visual data mapping and transformation tool is now part of the Logic Apps extension. So since we have merged into the extension from preview and become generally available, we now have a couple new features that we want to talk about really quickly. We've unlocked the function positions on the data map design page, so they are now movable to whatever liking you desire. And we've also updated the functions library to include various sequencing functions like filtering, sorting, and distinct values. Custom extensibility was also a big new change that we're really excited to bring. So that kind of brings the ability to create custom functions, custom XPath, and inline XSLT. And then finally, we now have the test API available, which I'm lucky enough to bring aboard Parisha here today to talk to us about this exciting new feature. So Parisha, I will let you take that on whenever you're ready. Wagner, if you want to switch over to his screen.
Thank you, Alex. My name is Parikshit Gupta, and this is my first time presenting into this forum. I am one of the engineers in BizTalk, in Logic Apps team, actually, working on backend and runtime side of the things for Data Mapper and business process tracking, which Kent earlier presented today. Before starting to work on Data Mapper, I was actually part of BizTalk Server team since the release of BizTalk Server 2010. Today I'm going to talk about some of the APIs which actually runs in the background and powers the Data Mapper. And through my sample code, I'll demo some of the code which you can use to actually automate your testing of the maps and also compiling the map into XSLT. Let me go ahead and share my screen. Alex, can you confirm you see my screen?
Let's see.
No, it's not been shared yet. So you click, Parakshit, you click on present, and then share a screen. Then now it's coming, and there you go. Just adding a two-stage. All yours. Inception effect.
Yep, thank you. Okay, so the code which I'm going to share today is already shared in one of the GitHub repository. This is the link, and we also actually released a blog article yesterday on the tech community about the same talk. The link to the repository is actually shared in the talk as well. So let's go and jump into directly what I wanted to talk about. There are actually 3 APIs which runs in the background to support the Data Mapper. First one is actually the Schema API. It's not very relevant to this talk, but anyway, I'll actually just give a brief overview of what this is. This actually resolves the schema, compiles the schema, and parses it to give the schema tree to the mapper to render and help in the mapping. The next API is Generate XSLT API. You can also call it Compile API. So the map is actually stored as in our mapping language format that actually not something which runs in the actual execution of the logic app. So this Generate XSLT API that compiles that map code into XSLT 3.0. And that is what is should be deployed and executes at the runtime. And the third and the final API is TestMap API. This API is used by the designer to in order to execute that XSLT against a given input, and the response is actually the output what you see in the mapper. So that is something we call it manual testing in the designer. But this talk is about how you can actually use some of the code behind these APIs to actually automate your map with many inputs. And that's what you need for, let's say, regression testing or making sure that your map is robust before you actually take it to production. So I'm going to share my Logic App, which is already in the sample. This is Logic App project inside VS Code. And I already have some schemas and maps already defined. The thing which I'm going to show is how the API is started. If you actually first start the Logic App Designer on the Map Designer, the design time API is started in the background. You can see in the output window, the function host is started on port 8001. You can actually grab this port and start hitting the API from Postman, but I'm going to show you this can be started outside the VS Code environment too. All you need is actually function host file and local setting file. The important thing in these two files are actually, if you see, standard host.json file, but all we need to tell is load the workflow extension bundle, and the setting is this setting is enabled to true, so that we know that we are running it in the design time mode, workflow operations discovery host mode. And the local settings.json file has an important setting, project directory path. I'm going to tell you why this is important through my examples. This should actually point to where your artifacts folder for the Logic App resides. If you go and see here, this is my artifacts folder in the Logic App project. Schemas and maps, they're already existing concepts in Logic App standard project. There is a folder called map definitions where all my maps generated through data mapper, the new data mapper, is actually stored. And there is a folder for custom extensions. If you see data mapper and the subfolder extensions, which actually stores my user defined functions and inline XSLTs. If you see my example map, I have used actually all three kind of custom extensions possible. When you need to use just a one-off custom expression, you can use XPath. As is actually a user-defined function which is defined in one of these files, sample functions age. And another extension which we actually have is the inline XSLT. So both XPath and the custom function can generate just one value for a given node. But if you need to generate a structure and value together inside a node, that's where you can define your custom inline snippet, and this will take care of actually generating that full XSLT snippet or the full structure of the XML node behind in your map. So let me go and show the generated XSLT for this. The generated XSLT for this map is actually self-contained. If you see all my custom definitions, the user defined function age is actually embedded here. The inline XSLT, which was defined for this map, is actually embedded in the XSLT. So this is what is actually running when the Logic App runs, and this is self-sufficient. All these files, all these folders, map definition, inline XSLT, and the user-defined functions are only design time requirements. So none of these actually should go into the deployment. Only thing needs to be deployed is actually XSLT. And the reason this folder structure is required here is because the compilation process needs to know where my inline XSLT is, where is the definition of the custom function or the user-defined function. That's why we need this fixed folder structure, and this setting, the project directory path setting, is required in the local setting. So I can go ahead and now I have host.json and local setting in my working directory here. I can go ahead and actually start the function host to start the API outside of the VS Code environment. I've already gone ahead and started it. If you see, my working folder has both these files, and I've already started function host on port 8001. And if you see, this starts also an .NET Framework worker. So what we do is from the test map API, we actually invoke the XSLT .NET Framework worker where the XSLT is actually executed. And this actually runs the Saxonica.NET Framework XSLT engine, where we actually execute our XSLT 3.0. Let me go ahead and show you how the request and response looks for the test map API. If you see, this is my URL in the Postman. This is actually on the management head of the logic app, and we are actually executing test map on a specific map, which is XML to order JSON map. And the request body is simple, just one field, input instance message. Inside that, we have a content, envelope content with the content type, and the content is actually base64 encoded string. You can go ahead and hit it. This will show you that it is actually hitting the API, which is actually running for me outside of the VS Code environment. Is where it shows that executing the NetFX worker. And here is your output. So output response is actually, again, just one field output instance, and with the enveloped content. My map was actually XML to JSON map. So that's why you see the output is actually content type JSON. And the content is actually just base64 encoded content. The same thing I have actually given in my sample code to actually run it through an API client. All you need is actually, if you see Mapper API client project, all you need is reference to our NuGet package, workflow extensions. And I'm just using a simple HTTP client to hit the same URL. This is generate, hit the same URL which I showed you in Postman. But the important thing here is that these are the two classes provided from the library, test map input, which is actually used to construct the content for this post. So you can take the reference of the NuGet package and start using these classes to create a client if you want. And the response from this API is actually deserialized into test map response class. So this is also similar to test map input class. It just has a field output instance with content envelope. I'm not going to run this API client. What I'm going to run is actually the code behind this API. I told you before that we actually start the .NET Framework worker behind this API, and that is what actually executes the XSLT. So what I have done is in the map tester project, I've actually taken a reference to another set of libraries which we can actually directly invoke the .NET Framework worker. So this is what is test map helper is another class I have provided in the sample. This is just constructing the input to invoke the library code, and there are a few things which are needed to bootstrap this class. I think one thing is you need to implement this interface and the host configuration interface, and you need a logger. And then you can start using this code to invoke the .NET Framework worker code, which directly executes the XSLT. I can go ahead and execute this code to show you how I've actually done some massaging around it. So if you see the output is input and output is little different from what the API was expecting. The input is the content of the input is very similar. You actually have the input file content as byte stream, and map the XSLT path, the name of the map, and we just set this flag to true that the code knows that this is actually coming from the map testing. In this test map API code, what we also do is we actually ensure that it executes the same code which will be executed by the workflow execution, so that you don't see the surprises when you actually execute the map in the test map environment, in the map designer environment, or you take it to the workflow execution. So the response will actually be same. The output from this code is little different than the API response. If the output is XML, you get the content envelope response. But if the output is JSON, you get the J token directly in the body of the response. This is some small things to note about this thing. Let me go ahead and execute this. So the command line is simple. It takes the map name, the XSLT file path, and the input instance on which you want to execute the map, and the output is dumped into this file, the student response file. So this doesn't go through the API. This bypasses the API and directly executes my the code behind the API, and the input and output you can see is dumped on here. Okay, so the next thing I'm going to show you is some of the tests I have written for my sample maps, which I showed you earlier. Two of the maps, which is X12 to order map and X12 to order JSON map. So these are similar maps, but the output side in one case is XML, and output in another case is JSON schema. Both schemas are actually same. I've just ensured that I just wanted to show you certain capabilities of the map code, but I'll come to that in the later part of the presentation. So the test project is actually on top here, the data mapper map tests. This is simply using the Visual Studio unit test framework. And the class is actually test class, and each of the functions are actually test methods. The way I have organized my test is actually by the map input output types. So one test is actually XML to XML transformation test. Another test is XML to JSON transformation test, but you are free to actually organize it in any other way. For example, it can be one test case for each of your map. And then each test case is actually driven by multiple inputs, and the test strategy is simple here. So I'm just executing the map against multiple inputs. This can take different map name also and different inputs. And the output is actually compared against golden output, which is already part of the project. The comparison here is simple. What we are doing is, in case of XML, we are loading the actual output and the expected output in X document, and using X nodes deep equals to actually compare that in case of XML. And in case of JSON, it's similar. We actually parse the expected output and the actual output into JToken, and then use the JTokens deep equals functionality to do that. This kind of comparison will work if the map is deterministic, and it always produces the same output for a given input. But the problem comes, this kind of comparison will not work when you actually have some kind of dynamic content in the map. For example, you can actually have something based on current date time, or you might be generating a unique GUID or a different number every time. So this kind of comparison will not work, but yeah, you should be able to employ different kind of mechanism to test to validate your expected output. Okay, so I can actually now go ahead and run this test to show you how it looks in the Text Explorer. I've already run it, that's why you see the output, but let me go ahead and run it again. Just give it a few seconds. So you can see it runs, but there are some failures. In both test cases, one of the input actually failed. And you can go and see the output. It says the output comparison failed, and the output file is actually dumped here. If I go dumped in the output, if I go and show you the difference in the expected and the actual output, the difference is just in the one field. In the expected output, it is actually expected to be uppercase, but the actual output generated from the test is actually not uppercase. So I know I have to go and fix the map now. All I need to do is make the customer contact name uppercase. So let me go ahead and try to fix the map. So this is where the mapping language which we have come up with is actually handy. So coming from BizTalk experience, I know this is a big advantage, the ability to actually go and edit understand the map code directly and go and edit it. And the map code is actually designed with principles of actually having intuitiveness and human readability, and also uniformity across different formats of the input and outputs. If you see these two maps, I told you this is XML to XML and this is XML to JSON map for the same scenario. You see both the maps look similar. In fact, they use the same construct, irrespective of whether the output is JSON or XML. The generated XSLTs for them, you see, they're quite different, just because of the fact that output is JSON in one case. You see maps and arrays in case of JSON output in XSLT. In fact, the map code only differs in JSON and XML case only when the JSON arrays scenarios, because the way JSON arrays are represented differently from the repeating records in XML. So let me actually go and try to fix it. The map, I know if you get familiar with this map code and the language, and you know what functions are supported, it's very easy to go and update it. So let me go ahead and fix the customer contact name to make it uppercase. I fixed my map. Let me go ahead and run it again, my tests. Give it a few seconds. It still doesn't work. The reason now is actually because my code is actually running the XSLT, not the map code. So I need to actually go and compile this map again to get the new XSLT. So that's where the second API I told you earlier, the generate XSLT API or the map compile API comes handy. So let me show you how that API request response looks like. This is my generate XSLT API path. This is on the same management URL head with generate XSLT path. And the request is simple, just one field, map content. The content of the map code goes as a simple string in the request, and the response you get is the XSLT, the compiled XSLT content as a plain string. The same thing again, I have actually in my sample code, I have this done through an API client in the same code, and there are the classes to actually support input and output for this API. So generate XSLT input is the class which is used to construct the content for this request, and the response is actually deserialized into generate XSLT response object. This is just few tips and tricks to use the API client for this API. Again, I'm not going to run this API, and what I'm going to show you again another code in the project generate XSLT, which is actually using the code behind the API. Directly using the library from our NuGet package. So this is again, we have taken reference to the NuGet package, and all we are actually calling is generate XSLT on the data mapper utility class. There are a few things needed to bootstrap before we can call it. There are a few statics to be initialized. You need to initialize flow configuration. And again, earlier I said project directory path is important for the compilation process because it needs to know where the custom extensions code exists so that you can actually go and the compiler can go and find out those things and embed those things in the generated XSLT. So let me go ahead and quickly compile my map into XSLT. I have it. This is for the JSON map, XML to JSON map. And this is for the XML to XML map. So now I have actually my map compiled. If I go ahead and execute this test now, give it a few seconds, this should now pass because I actually have the updated XSLT for these maps. This still fails. Okay, I think this is not expected, but yeah, we can go ahead and fix it. What I wanted to show you another thing was for this change which I did for my map, I went ahead and actually raised a pull request into my repo. So if you go ahead and see the pull request for this change. So irrespective of whether you actually change your map either in the designer or in the map code directly, if you actually take that update through the code review process through pull requests, you can actually identify the logical changes in the map and ensure that the changes were done right and really take the full advantage of the map code and the new mapping language features. Yeah, that's what I actually had to share. Back to you,